Today we are going to study about potentiometer. What is potentiometer? Potentiometer is a device used to measure the potential difference between 2 points. Now till now you have been studying about voltmeter and how voltmeter is used to measure the potential difference between 2 points in any given circuit, right? So if I have a circuit diagram over here, if I have a circuit diagram over here, and uh, this is the battery which has an EMF of E, and a current of 10 ampere is flowing through it. A current of 10 ampere is flowing through it through a resistance of 1 ohm. 1 ohm is the resistance. We have connected an ammeter in series with this 1 ohm resistor to measure the current. Now, what is the voltage across this 1 ohm resistance? We are going to use the Ohm's law, right? So we have V is equal to IR is the Ohm's law. I is how much? I is 10 ampere and R is the resistance, and that is equal to 1. So I get the answer as 10 volts. So what does that mean? We have a voltage of 10 volts across this 1 ohm resistance. Is it not? Now to measure this potential difference, I am going to connect a voltmeter across this resistor. When I connect a voltmeter over here to measure the potential difference, what happens is this 10 ampere which was flowing through this wire through the 1 ohm resistance now gets divided into two parts. One part is going this way, and some small current out of this 10 ampere will pass through this voltmeter. It will pass through this voltmeter. Suppose 9 ampere current is flowing through this resistor and 1 ampere current is passing through this voltmeter. Out of this 10 ampere, 9 ampere is going to the 1 ohm resistance and 1 ampere is going through the voltmeter. But now the problem has happened. What will the voltmeter measure? Now the voltmeter will measure the potential difference as V is equal to IR, where I has now become 9 ampere and R is 1 ohm. So it is going to measure a value of 9 volt. Okay. The actual voltage was 10 volt potential difference, and now it is measuring a potential difference of 9 volts, right? So this is the problem with the voltmeter. It is going to measure a potential difference which is not accurate. It is going to give us a potential difference which is little lesser than the actual potential difference. Okay, so what can be done about this? To decrease the amount of current, to decrease this current flowing through the voltmeter, I can increase the resistance of this voltmeter so that little current flows through it. Okay, but some current will definitely be flowing through this voltmeter. If I want all 10 ampere current to flow through this resistor, all 10 ampere I want to go through this, that means this voltmeter should draw zero current. If I want zero current to be passing through this voltmeter should have an infinite resistance. It should have infinite resistance, which is not possible. Okay, so this voltmeter is definitely going to draw some current, because of which we will not get accurate readings. Right? So we need a voltmeter which is ideal to get the accurate reading. What does an ideal voltmeter mean? Ideal voltmeter means that this voltmeter does not change the potential difference to be measured. If the potential difference is 10 volts, it will measure as 10 volts and not 9 volts. Okay, and it should not draw any current from the circuit. It is impossible to have a voltmeter which fulfills these two criteria, but we do have an instrument which gives an accurate reading of the potential difference and which does not draw any current, and that is the potentiometer. That is the potentiometer. So potentiometer, we can call it as ideal voltmeter. It is the ideal voltmeter. It is used for accurate measurement of potential difference. Okay, so first let's see how this potentiometer looks like. So this potentiometer is like this. It is nothing but a wire. See, this is the wire. Can you see thin wires over here? It is one complete wire. It turns there and comes back like this. Here also it turns and it comes this way. Okay, so we have one full stretched wire on the which is fixed on a wooden board. This is the wooden board. This is the wooden board. So on this wooden board we have this very long wire which can be 2 meter to 10 meter long, and it is made in rounds such that one edge is 100 centimeter. From this point A to a point over here, the length is 100. So in this particular potentiometer we have a 400 centimeter wire or a 4 meter wire, right? So this is a typical potentiometer. Now let's see the construction of this potentiometer. So potentiometer consists of a uniform wire AB which can be 2 meter to 10 meter long. It is stretched on a rectangular wooden board into number of segments 100 centimeter each. Each segment is 100 centimeter. A meter scale is fixed parallel to its length. Okay, see, this is the meter scale. This is the meter scale. It is fixed parallel to the wires, okay, so that we can take the readings. That is the meter scale. A is connected to the positive terminal of the driving source E, and B is connected to the negative terminal through the key. So this terminal A is connected to the positive terminal of the driving source or the battery, and B is connected to the negative terminal, okay, through the key. Many a times a rheostat is also attached over here. We can attach a rheostat over here. Okay, so this is a typical potentiometer that we are going to use. Now the main important thing in this potentiometer is that it has a uniform cross section. The wire has a uniform cross section. This part is very important. It's not that the wire is thick somewhere, thin somewhere. Okay, the cross section is uniform. Area of cross section is constant. This will ensure a fixed resistance drop or across the entire wire. Now let's see the potentiometer principle behind how this potentiometer works. Now for that I have drawn this circuit diagram. This is our potentiometer wire AB. Okay, between this points A and B is our potentiometer wire. This is the potentiometer wire, and I have just shown it in one straight line. Okay, just for the sake of ease in drawing this diagram. We have a source of EMF connected over here, that is the cells or batteries having EMF E. Current I is flowing through it. Okay, so what is the principle behind this potentiometer? Let's see. So when a steady current is passed through a wire of uniform cross-sectional area, the potential drop across any portion of the wire is directly proportional to the length of that portion. Now if you read it like this, it is a little difficult to understand. So let me simplify this principle for you. What does that mean? That when a steady current is passed through uniform through a wire of uniform cross sectional area. That is, when you are passing current I through this wire AB, then what is happening? The potential drop across any portion. If you take any portion of this wire, suppose I consider just one part, that is from this point A to some arbitrary point C. Okay, I am considering this part of the wire. So potential drop across this wire, let that potential drop be VAC. The potential drop across the entire wire, or the potential difference, is VAB. Across AC, it is VAC. Okay, so according to this principle, the potential drop across any portion is directly proportional to the length of that portion. So VAC is proportional to the length of this portion. Let me call it as small l. Okay, so we have VAC is proportional to L. That means if we increase the L, potential difference is going to increase, or the potential drop is going to increase. This is what it means. Now let's see whether it is true, whether it is really like that, and why it is like that. Let's see that part. Okay, so now let capital L be the length of the wire AB. Capital L be the length of the wire AB. Capital R be the resistance of the wire AB. Capital A is the area of cross section. E is the EMF of the cell, and small r is the internal resistance of the cell. Okay, now the current through AB, the current flowing through our wire AB, I, we have denoted it as I is equal to E upon R plus R. E is the EMF of the cell, R plus R is the total resistance in the circuit. So I get I is equal to E upon R plus R. What is the potential difference across AB? If I call it as VAB, potential difference across AB, this one. Okay, VAB. That is equal to current flowing through that wire AB into the resistance of that wire AB, right? So current is equal to E upon R plus R, and capital R is the resistance. So I have just got it from here. From this I have got it. Okay, so I get this. Just I has come over here. Okay, now potential difference per unit length. We want to find the potential difference per unit length. What is this? E upon R plus R into R. This is equal to VAB, which is the potential difference across the entire length. Okay, so for length L, if the potential difference is VAB, what will be the potential difference for unit length? That will be VAB divided by L. So I divide both the sides by L. So I get VAB upon L is equal to ER upon L into R plus R. Now all these parameters are constant. For a given length of wire, R is constant, L is constant, R is also constant. So provided we don't change the cell, E and R will also remain a constant, and hence this VAB is going to be a constant. That is called as the potential gradient. For a given wire, this VAB upon L is a constant and it is called as potential gradient. Okay, it is denoted by K. K is equal to VAB upon L, where K is the potential gradient or the potential difference per unit length of the wire, right? Now let's try to find this VAC. We wanted to prove that VAC is proportional to L, no? So let's try to do that. Okay, so VAC, what will be the potential drop across VAC? So I can use the same thing. If for unit length potential drop is K, then for length L, what will it be? So I can write it as VAC is equal to K, where K is the potential difference per unit length, into the length. Is it not? And K is a constant. K is a constant. So this implies that VAC is proportional to L. VAC is proportional to L. Okay. Thus we have seen that this statement, what is given as the principle of potentiometer, is correct. We do get VAC is proportional to L. What does that mean? As you go on increasing the length of this segment of wire, the potential drop across it will go on increasing, So this simple thing we are going to use for finding the potential difference across different resistors and many other things, which we will be studying in further classes. Okay, so this is it about the potentiometer principle. Thank you.